Doing some simple investigations will allow us to understand how the gas laws work. Now, the gas laws describe how an ideal gas behaves, but at normal temperatures and pressures, most gases behave pretty closely to ideal. That will allow us to use these equations to make some pretty accurate predictions about the behaviors of gases. Boyle's Law describes the relationship between the pressure and the volume of a gas. Now, for Boyle's Law to work, the number of moles of gas, the amount of gas, and the temperature of the gas need to remain constant. Now, I can demonstrate Boyle's Law and the relationship between pressure and volume just using this water bottle, which has a test tube inside. The test tube has been turned upside down so that there's a big bubble of air inside the test tube. I can change the pressure inside the water bottle simply by squeezing on it. So as I squeeze on the water bottle, I increase the pressure, and you can see that that decreases the amount of space that the bubble takes up. It decreases the volume of the gas. That's because pressure and volume are inversely proportional. As one goes up, the other comes down. Charles' law describes the relationship between the volume of a gas and its temperature. Now, for Charles' law to work, I need the number of moles and the pressure of the gas to remain the same. But I can demonstrate Charles' law and the relationship between volume and temperature very simply. I just need to blow up a balloon and then heat up the air inside the balloon. Here you can see that as the temperature of the air increases, the volume that the air takes up also increases. That's because volume and temperature are directly proportional. As one goes up, the other goes up as well. Avogadro's law describes the relationship between the volume of a gas and the number of moles of gas. Avogadro's law assumes that the temperature and pressure of the gas remains the same. I can demonstrate Avogadro's law by doing a simple chemical reaction that produces a gas. This increases the number of moles of gas that are inside a container, and then I can observe how the volume changes. Here you see that as the gas is formed, the gas inside the container takes up more space and inflates the balloon. That's because volume and number of moles are directly proportional. As one goes up, the other goes up. So we can put these gas laws together into what's called the combined gas law. And the combined gas law allows me to predict how any two variables would be related if the other variables are kept the same. So for example, we already saw that pressure and volume are inversely related. As the pressure went up, the volume went down. And notice they're on the same side of the line. That tells me that they're inversely proportional. That as one increases, the other decreases. So I can also predict that the number of moles of gas and the temperature of gas are also inversely proportional. If I want the pressure and volume of a container to stay the same and I increase the number of moles, then I need to decrease the temperature. So they're inversely proportional, and I can tell that because they're on the same side of the line. Now, we also just saw that the number of moles of gas and the volume of gas are directly proportional. That as I increase the number of moles of gas, the volume of the gas will increase too if the pressure and temperature are kept the same. And if I increase the temperature of a gas, the volume of gas also increases if I keep the number of moles and pressure the same. So those are also directly proportional. And notice they're on opposite sides of the line. When variables are on opposite sides of the line, I predict that they will be directly proportional. So I can also make predictions about variables that we didn't examine today. So for example, if I increase the number of moles of gas, I would also expect that the pressure of gas would go up if the volume and temperature were kept the same. Now they don't just increase together, they also decrease together. So if I removed gas from a gas tank, then I would expect the pressure inside to go down if the volume and temperature of the tank stayed the same. Using the combined gas law, we can make predictions about how one variable will affect the other. I hope this video has been helpful. Keep up the great work. I'll see you next time.